Uh, Hi everyone, we are back with a new problem of TSA. Today the problem is remove duplicates from sorted linked list 2. So previously we did the code in which the code was remove duplicates from sorted list. So that was problem number 83 of Leet code. Today we are doing problem number 82. So in that problem it was given a linked list. In that we just have to remove the occurrences, means if one value repeated more than one times, so we just have to remove its occurrences and return the value only of single time. But today this problem is quite different. In this, again we were given with a sorted linked list, and in that what we have to do, if suppose any number is repeating more than, if any number is repeating, suppose 3 is of 2 times and 4 also is of 2 times, so we just have to remove both 3, the whole number 3 and 4, means we don't have to take 3 and 4 in our final output. So as we can see over here that 1 2 3, since 3 is repeating more than one times, or we say 4 is there more than one time, so we just remove 4 and 3, and in final output we include only 1 2 5, which are only of one time. And as we can see over here also, since 1 is repeating 3 times, that's why we remove 1 and we take only 2 and 3. So previously we did code of remove duplicates, but in that we were taking only one number at one time. But in this time we just have to check, not only have to check the occurrences, but have to remove the number completely. If any number repeats itself, then we will remove it completely. So now came to the logic part, that how we will going to solve this problem, and what will be our implementation. So as you can see over here that we are taking three variables: current, which is pointing to this head node; previous and temp are currently on none, so they both are none, but previous or next of previous is pointing to this one, and next of temp is pointing to this one. Now why we are doing this? We will not touch this temp because it will go for final printing. So the next of this temp is always pointing to this head. Now why we are taking next of temp? Because suppose if the number repeats from one itself, from head node itself, then we have to remove that. So in that case, the next of temp will shift to the next element. That's why we are repeating next of temp. And previous, we are taking initially at none, because previous will be one step back to this head. Now let us discuss how we're going to. So we will start from this current, and we will check that if this current is equals to the element next to it, since this is the sorted linked list, means all the elements which are equal and all the elements which are repeating are adjacent to each other. So we will take advantage of that. Now we will check that if this one is equals to 2, no it's not, then current will shift to this 2, and this previous will shift to this 1. So let's take another color. So current will came to over here, and previous will came to this 1. Okay, now again, sorry, I have to write C over here. Okay, so now we will check again that if this 2 is equals to this 2, yes, condition gets false. So now at this time, the previous is here only, but the current will move from here to here. And again we will check that If this element is equals to the element next to it, yes, the condition gets true. So current will again move to this. Okay. Now you can see over here. After this, we will again check that if this element at which current is there, is it equals to the element next to it? No, condition gets false. So condition gets false, then also we will move one step ahead. And again we will check if this 3 is equals to this 4. No. So the condition gets false. Now at this time, the repetition gets stopped. As the repetition of 2 gets stopped over 3. So we will shift the pointer of previous to this 3. Since this 4 is not equals to 3, the current will go over here before all. And again we will check that if this current is equals to this 5, no, the condition gets false. So current shifts over here, and this previous is on 3, so it came to at this 5. Sorry, 4. And current is over here. So after that there is null, so no need to go on this. So I hope the logic is clear to you all, that how we will going to implement this. So let's come to the coding part. Let's see one more thing, that how it will going to print. So in final printing, we will return this temp of next. So we know that temp is on currently is on none, and temp of next is pointing to this one. So in final printing, it will start as 1. Then after 1, we know that since we have removed these 2, as our previous is now pointing to this 3. So means after 1, the 1 will start pointing to this 3. Now 1 is not pointing to these 2. So ultimately they get removed. After 1, 3 will come, and after that 4 will come, and after that 5 will come. And 5 is pointing to, sorry, this null. Okay, so we get our desired output. Let's come to the coding part. So how we will going to, so as we have discussed that we are declaring some variables. Current equals to head, as it is pointing to head, and temp equals to previous equals to list node and none. Initially they both are none, and temp of next, temp dot next equals to current. So now we will implement a loop, as we have to traverse through the linked list. So we will traverse like while current and current dot next. So it is something like this: while current does not equals to none, and current dot next does not equals to none. Since we are just checking between the adjacent element, means the element at which we are and the element next to it, that's why we are taking current and current dot next both into consideration for this loop purpose. Now we will check that if current dot well equals to current dot next dot well, means the element at which current is there and the element next to it, if they both are equal, then again we will implement a loop. As I discussed in logic part, that suppose if current reaches to over here, then the previous keeps here only, and this current will keep on moving up to the time these elements are getting equal to the element next to it. Means 2 is equals to this, the element next to it means 2 is equals to 2, again 2 is equals to 2. So current keep moving here only up to it is equal. So again we will implement a loop while same thing current, the base condition is same over here also, while current does not equals to none and current dot next not equals to none. And one more condition is that and current dot well equals to current dot next dot well. Means we are implementing this loop just to point our current at the last position of repeating element. Suppose this 2 is repeating again and again, so we are just shifting our point to the last element of this repeating element. So it is came, so we just move current ahead step, means current equals to current dot next. That's it. Our loops end. So our loops end at which point? At the last point of repeating element. So we know that we came up to the last, sorry, my mistake. So we know that we came up to the last element of repeating element. Means suppose if this 3 is repeating, so now current is reached over here. So we have to shift our previous to the element of non-repeating element. So what we have to do, we have to move current one more step. So current equals to current dot next, and now we will shift our previous of next to current. And previous dot next equals to current. So let's notice one thing, that here I have written that previous of next equals to current, but still previous has not shifted itself to current. Means suppose if this 2 is repeating up to 3 times, so previous is here only and 3 came, so 3 is non-repeating element, so previous of next is pointing to this tree. But now suppose think like that, the linked list is like this: 1, 2 is pointing to this 2, and again 2 is pointing to 3, and 3 is pointing to this 3. Means so when 2 start point repeated, so current came over here after in a loop, but previous is over here. So now previous start pointing to this 3, but we can see over here that 3 also is repeating. Suppose after 3 there is 4. So logically the previous have to point this 4, not to this 3. So previous of next pointing to this 3, but previous is still over here. It is not shifted to this 3. So again, when the loop keeps on going, and again it will check that if this current element is equal to this. If it happens, then again it came in a loop, and same current shift to here, then current shift to here, and finally again we point our previous to this 4. And when we check that this 4 is not repeating, then only we shift our previous to this. So I hope that the logic is clear to you all now. So we had pointed the next of previous to current, and if suppose that it is not repeating, suppose if this else if condition gets solved, then we came in else, and what we will do, we will move previous equals to previous dot next. Now we shift our previous to one step forward and current also. Current equals to current dot next. And finally, as I said that we are not touching this temp just for printing purpose, and the temp of next is pointing to this current, so we will shift our, we will return this point of next is still pointing to the head node and the non-repeating element. Return temp dot next. Gets complete. Let's run it. Okay, the example is working fine. Okay, so it is working completely fine. Let's recall the logic again. That's what we are doing. First, we are just taking the variables over here. Then we have implemented a loop just for traversing the linked list. Then we have checked the condition that if the current element is equals to the element next to it that we have discussed in logic. Then we have again implemented a loop just for reaching the last element of repetition. Means if one element is repeated up to n times, then the loop current will reach to the end element of the repetition. Then we will shift current to one element to the next of it, and we will point the next of previous to this current. So the previous of next leaves all the repeating elements like this way, and still the previous has not shifted on current. So it will again go to loop and check the condition, then only previous will go to next of it. So this is a Python solution that we have. So we have implemented the same as per the logic that we have discussed earlier. So let's see the C++ solution also. So this is our C++ solution. It is all same. So I am removing it. It is of no need. So let's run it. Okay, it is working fine. Okay, so the solution was fine. As you can see over here that the logic is all exactly same that we have discussed, and the code is almost similar to the code that we did in Python. Only there is a bit difference in syntax, like for we are declaring current as list node, current list node temp, and temp of next equals to current, and list node previous equals to temp. So both previous and temp are pointing just uh, pointing to the next of previous is pointing to current, and both temp and previous are on none, or we can say null. And the same the loop for traversing the linked list and checking the condition if current of L equals to current of next of L, and while loop for reaching the end of repeating element and current equals to current of next. And similarly previous of next is pointing to current, means it leaves all the repeating elements. Then the else condition, if this condition gets false, we go to next, and simply previous equals to previous of next and current equals to current of next. So the code gets complete over here. We have seen both the solution in Python as well as in as well as in C++. This is our C++ solution, and this is our Python 3 solution. Same as we have discussed in the logic part. So thank you for watching. We will meet again with a new problem of TSA. Thank you. Till then, keep on learning.